Unreal Engine 5.3 preview just came out, and one of the features that blew my mind was the new support for VDB simulation files. But wait, what are the VDB files in the first place? If you ask Google, VDB is short for Volumetric Data Blocks. This was the first time that I heard about VDB, but apparently these extensions had been out there for a while in the VFX industry. That's because, in my understanding, these VDB files are for 3D world, what EXR files are for compositing and editing world. These VDB files can hold volumetric information such as fire simulation, smoke simulations, and a lot more of simulations that you can do in softwares like Houdini, Maya, or even Blender. And these files can hold a lot of simulation details, but keeping an optimized performance and render times. Now in Unreal Engine, if you use the particle system, you know that the quality of these particles are pretty okay, nothing spectacular actually. But then Epic Games introduced Niagara simulations. This Niagara system is an alternative for the old particle system that honestly it looks a lot better. But the fact that we now can import our own high quality pre-baked simulation into Unreal Engine, it's just mind-blowing. And actually this gonna change completely the way that indie developers and filmmakers work. So stop talking and let's jump into Unreal Engine. Okay guys, before we start, we have to know where to get these VDB files. For this tutorial, I'll be using these free VDB files that you can get on the Django FX page. I'll leave the link on the description below so you can get one of these free assets for your project. You can use them on your production or just for fun. And all the simulations that you're gonna see on this video are from this page. But if you know how to make simulations in Houdini, Maya or Blender, you can also export those simulations as VDB files and then keep following this tutorial. So now that we download the asset that we wanted to use, we're gonna unzip it and we're gonna look for the files that are inside of this folder. And you'll see that there's a lot of files. We could say that these files are actually the frame rate of the animation. So the only thing that we have to do is import the first frame, which is the file 0. We just have to click it and drag it into the content browser, and then this window is gonna pop up. The only thing that you have to do or check is that the option of import sequence is checked. That's essential for this animation. If you haven't still, you can just leave it unchecked. And in Attributes A, you have to check that the pieces of your simulation is well split into RGB channels. For example, for this case, the channel R represents the density of the simulation, channel G the temperature, and channel B the flames. This could be different, so don't stick out with these same settings. So if you have the same settings, there's no need to move anything. And we'll just click Import. That's gonna take a couple of minutes depending on your PC, so I'll suggest you to be patient. Once that importation is finished, you're gonna see that there's a new file in your content browser. So guys, now we have to create a new material. The original creator of this material is the Twitter user, well, now ex-user, Thibault Lambert. All the credits for him, and I personally suggest that you go and check it out, his Twitter or his X account, because there you can see all the work in progress that he's been doing with simulations and VDB files. His simulations work, it's just amazing. And something else that you have to be aware is that this whole process didn't work on my first try. I think that happened because I was using the black game template. And when I was creating this material, this message showed up. So that message makes me think that maybe Substrate had something to do with it. But then I tried to make this same process in the FPS template and it worked completely fine. So that's something to keep in mind. Let's continue the tutorial. Just by right-clicking on your content browser and we're gonna select Create New Material. Now we're gonna rename this new material as m_VDB_explosion. And then we double-click it, so now we can modify this material. On the material graph window, now we have to make a couple of changes of the type of material that we're creating. We're gonna go to the details panel on the left and we're gonna change the material domain as volume and blend mode as additive. Now you're gonna see that a lot of properties of our material now are disabled, and that's okay, that's completely fine. From this point forward, we're gonna follow this same material that the creator posted on his Twitter or X. I'll leave you a link on the description of this same image so you can have it too. Pretty much you have to create the same nodes that are in the image with a couple certain details. Stick with me on this tutorial, we're gonna make it step by step. So now we're gonna start pressing the number 3 and left clicking anywhere on the material graph. So this way we're gonna create this 3 vector constant and we're gonna connect the white dot into albedo. And then we're gonna double click on this black box and we're gonna set it as white. We're gonna right click it and convert it into a parameter. And then we're gonna rename it as scattering color. Right away we're gonna pull the emissive color to create a new node, and here we're gonna type multiply. Now that we have the multiply node, we're gonna press the S button and left click anywhere on the material graph. So we create a scalar parameter. This node we're gonna rename it as black body parameter, then we're gonna connect it on the multiply B. After that we're gonna look for the black body node and we will connect it to the multiply A. And finally we're gonna set the black body parameter to a value of 1. After that, pressing the key M and left clicking anywhere, we're gonna create a multiply node. This multiply node we're gonna connect it into the black body temp, and then we're gonna create another scalar parameter. This time we're gonna rename it as temp multiply and set a default value of 1. After that we're gonna pull out the multiply A node and we're gonna look for the remap value range node. It's gonna pop up this error, don't worry, it's completely fine. So now, pressing S and left clicking anywhere, we're gonna create 4 scalar parameters. And these all 4 scalar parameters we're gonna connect it into input low, input high, target low, and target high. After that, we're gonna rename them as remap input low, remap input high, remap target low, and remap target high. And then we're gonna set a default value of 1 on the node of remap input high and remap target high. Then with a right click, we're gonna look for the component mask node, and then on the details panel, we're gonna uncheck the R channel. After that, we're gonna right click anywhere on our material graph, and we're gonna write reroute node. You're gonna see that this little dot is going to appear. We just right click it and we're gonna press convert to named road. We're gonna connect it with our mask and rename it as temp, and connect it with our input on the remap value range. Okay guys, we're almost there. Now we have to look for the Sparse Volume Texture Sample parameter node, and we're gonna connect it the attributes A to our mask. After that we're gonna pull out the UV's input and we're gonna look for the divide node. Pulling out the divide A, we're gonna look for the subtract node, and from the subtract A input, we're gonna pull it out and look for the local position node. After that we're gonna create the object local bounds, and we're gonna connect the extend output into the divide B input, and then we're gonna connect the minimum output with the subtract B input. Okay guys, we're gonna take a look of our material. Now we're almost done. And now we're gonna create another component mask, but this time we're gonna leave the R channel. After that we're gonna pull out the attributes A and connect them with this new mask. Then we're gonna create another reroute node, and same process, we're gonna right click it and convert it into name reroute. We're gonna rename it as density and connect it with our mask. We're gonna create another scalar parameter, and this time we're gonna rename it as density multiply and set a default value of 1. And finally we're gonna create another multiply node and connect the density with A and the scalar parameter with B. And the multiply node we're gonna connect it with the distinction input. Now guys, we are done with our material. Now you can copy and paste this material as many times as you want. You don't have to redo any of this thing that we have done, and you can reuse it as many times as you want. Now we have to make one last thing. On the Sparse Volume Texture Sample parameter, we have to select it, and on the details panel on the left, we have to select exactly which animation we want to reproduce. Down here on the Sparse Volume Texture, we're gonna click on the arrow and it's gonna display a list of all the animations, all the VDB files that we have imported. So here you have to select the animation which you're gonna be using with this material. So in my case, I'm gonna select the gasoline explosion, the only one that I have imported, and then we're gonna hit apply and save this material. Okay guys, now we're done. The only last thing that you have to do is right click on the material and hit create material instance. This way we can play around with the parameters that we created. We're gonna double click this material instance, and as you can see, this new window is gonna show up. And now we're gonna create the item that is gonna be reproducing this VDB file. This is really easy. We're gonna click on this icon and we're gonna click on where it says all classes. And right here on our keyboard, we're gonna type heterogeneous. And you're gonna drag into your scene this heterogeneous volume. you're gonna see that it displays a reptile or dragon logo. And the only thing that we have to do is select it and drag the material instance into the details panel. Now we have everything set up. The only thing that we have to do is tell Unreal Engine that this material, this VDB file, is animated. That's pretty easy. We're gonna scroll down and we're gonna check the animate checkbox. And as you can see, now we have our explosion, our volumetric animation working completely fine into our scene. We're gonna scale it up a little bit. And now as you can see guys, this look really nice. Now with our material instance open, we can play around with some values, which I suggest you to modify the temperature, black body and density. The temperature multiply, it's gonna increase the quantity of the fire, as you can see right here. Now we have fire. Now the black body parameter is gonna modify the brightness of the entire volume. I suggest you to keep a low value, between 1 and 2. And finally the density multiply is gonna modify, well, the density of the smoke. And guys, I think those are the basics modifiers that you can use so your explosion or your simulations can fit better into your scene. And let me tell you that this looks really nice. That's because in my mind I'm comparing this same volumetric explosion, this same volumetric simulations with the old particle system, and let me tell you that I haven't seen anything so realistic, looking so good in Unreal before. I know Niagara it's evolving really fast, but guys, this is so amazing just by the fact we only have to make this unique material, and that's all that you have to know. Learning Niagara and the particle system, it's something kinda annoying and kinda difficult for a beginner, so I think this is an amazing solution for Unreal and for beginners. And guys, take a look at this. If we play around with the sun and the illumination, you're gonna see that this simulation or the lighting of the simulation, it's being affected by the lighting of the sun. I mean, guys, just look at this. It's just an eye candy for me. But yeah, I'm well aware that right now not everything is super cool. As you can notice, there's a huge lack of emissive lighting, so it doesn't matter how bright our explosion is, there's no lighting emission. My simulation doesn't affect any of the lighting of the world, so I think that's an important problem right now. We're just gonna have to wait for the next update, how this integration keeps evolving. Remember that this could be an alpha version, an experimental version. This is not supposed to be used on final productions, on video games, or anything actually. This is just something to play around, to test it out, and we're gonna wait patiently for the day that this feature is released as a production-ready feature. So guys, finger crossed. So that's it guys, I hope that you're so amazed like I am right now. Just remember that this is still an experimental feature and you saw that there's still some graphic problems, but it's still amazing what you can do in Unreal Engine on these days. And personally I think that Unreal Engine right now it's a big deal on the VFX industry, game industry and whatever industry that you want. Unreal Engine is a big deal. So, what do you think about it? Will you use these new features in your productions? I wanna read everything you think down here in the comment section. And now that you're down there, click the like button if you liked the video or if you learned something new today. Subscribe to the channel and hit the bell button so you don't miss any of the new videos that we upload on this channel. You can support the channel sharing this video with the people that you think that this information could be helpful. And by the way, thank you so much for all the people that is subscribing to the channel. You have no idea how much I appreciate that. So much thanks guys to Michael Re, Gerson Gabriel, Firtu, Nestor David, Electrical Fabrication, Mikhail Sivatsky, Andrei Paredes, Chacalo, José Enrique, Andrei Herrera, Miguel Ángel Reneike, Roger Cervantes, Baguro, José Fernando Guerrero, Abseeker, Gerardo García Padrón, Rubén del Valle Prada, Luis Tafur, Jonathan Andrés Osorio, Claudio Camaño, Mauro Bambosi, Arley Fernández, Make, El Canal de Beck, Andrés Felipe Cárdenas, AR Print 3D, Lux Studio, Jorge Henao, Miguel Ángel Argañaz, Ale Render, Imaginario Cinético, Víctor Skripnik, Miguel Ángel Iglesia, Javier Romero, John Ray Duldulao, Germán Hidalgo, Faz, María Tereseña, and Elijah Bon Bagay. And I know that there are a lot of people that came from my main channel that I didn't mention, so if that's your case, please leave a comment down here so I can mention you at the end of the next video. Follow us on our social networks like Facebook, Instagram and TikTok, as well as on my Instagram, TikTok and Spotify accounts. Thank you so much for watching this video and remember that this is Exvia Studio Cinematica, and I'll see you on the next video.